Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We've been working on this Bally Matahari pinball machine. We did a video on it already. This thing is a prototype. It's one of the 20 that had the plastic playfield. You don't see them very often. We had this one in once before and repaired it, did some minor repair on it for a gentleman, and he put it in his rental house at the beach. And it started acting up again, and so he brought it in just to have service done on it. So we're trying to go through it and make it as reliable as possible. One of the things we did was we replaced the end of the power cord, and we are about to go through every little thing we can to try to get it as reliable as possible for him. Let me take the back glass off, and we're going to go ahead and pull out the power supply so we can work on that a little bit and just see what kind of condition it's in, make sure everything seems right, and we'll go from there. Now, I will note that one thing that's obvious is that all of the not the general illumination, but the computer-controlled lights aren't working. If you look on the back glass, none of them are on either. So we need to see what's up with that. It might just be where I didn't plug something in. This thing was taken apart whenever we brought it in. Maybe I didn't plug something in on the light board. Maybe there's a fuse blown, bad connection, whatever. So we'll check it out. Let me take the glass out. Alright folks, so here is the power supply. Now there is all of the boards and everything in it. Nothing is going to be any different than the production stuff, even though it's a prototype, because this wasn't the first Bally solid state game. And the only difference in the boards between it and some of the other games is the ROMs. So we looked it all up on the previous video. At the time that this was designed, the prototype would have been in September and October of 77. And at the time, 8-ball was on the assembly line, so the parts would have been repurposed 8-ball parts, likely. So let's see. We don't have any of our lamps. I looked on the lamp driver board, and it was plugged in. So let's see if any of these fuses are bad. That one's good. This one looks bad. That one's good. That one's good. That one's good. That one's good. Now you might be wondering, why am I getting kind of readings that aren't zero? It's because of just tarnish and stuff on the fuse holders. That one's good. And that one's good. All right, so this is our meter that we got from Todd a while back. Todd actually stopped by the shop last week and was here a couple days. His son was in town playing disc golf, and he made it to beautiful downtown Rock Hill, South Carolina. So we appreciate him stopping by, and thank you again, Todd, for the fluke. So that works fine. So I'm going to check these bridge rectifiers. If one of the bridges was bad, it would blow the fuse, though, so I doubt there's anything wrong with those, but we'll check them. I'll show you how to do that really quick. If you look on these, this is just common stuff with these Ballys. If you look on these bridge rectifiers, there are 4 pins for each one, and there's a screw in the center holding them in place. There's 3 of them. Okay? One of the corners is marked negative, one's marked positive, and the other 2 are marked AC. So the way you check a bridge rectifier is you put your meter on diode test, and a bridge rectifier is just 4 diodes arranged in a square. So you take your common lead, or your negative lead, and you put it on the plus mark. So you do it backwards. And then you measure the diode, the transistor diode setting, diode check, from there to the AC pin adjacent to it, and you should get something between like 0.4 and 0.7. So 0.5 and 0.5, and then you reverse it. You put your positive lead on the negative, and then you check again from there to the AC. 0.5 and 0.5. And after you've done a little bit, you can go through it really quick. 0.5, 0.5, 0.5, 0.5. This one's been replaced. Maybe by us, I don't remember. 0.5, 0.5, 0.5. Okay, so those are all fine. So the 3 bridge rectifiers are fine. We can test these 2 resistors. Now these resistors look bad. They look all screwed up. But they just do that. They get toasty. Anytime you've got like a sand resistor like this, especially on this vintage equipment, it's because they're literally burning off power. So they get hot. That's what they're supposed to do. That's why they used this thing, right? So we can just see, though, if they're anywhere near spec. This says that it is a 600 ohm. And it's 606. It says it's a 10% 600 ohm. So it means it can be anywhere between 540 and 660, and it's fine. And it's at 606, which is right in the sweet spot. All right, and then there's this one. I think it says 25 ohm or something. 23 ohm? 25 ohm. And it is 70 ohm. Ooh. Let me see if it really does say 25. Am I seeing stuff? Yes, it does say 25 ohm. Am I doing a good job of testing it? That's the next thing we'll check. It's saying 70 ohm, bigger than hell. I wonder if that'll test fine in circuit. Do I have another 25 ohm? Let me see what I got here. I got a 27 ohm. That's within spec. Is that a 5 watt though? Yeah, 5 watt. I've got a 27 ohm 5 watt. Maybe we replace that. Let's look at the schematics and see what that even does. All right, so here are the schematics. That resistor is used on the solenoid line. Well, that can't be right. No. 5.4 volts DC. That is actually the lamp line that we're missing. Yeah, switched illumination, they're calling it. Okay, well, let's replace it. Just so we know for giggles that that's correct. And that's bridge 1, it's saying, which is not a bridge that we have replaced yet. So it could be that that bridge is testing good with the meter, but it's bad once there's voltage running through it. There's test points there that we can check whenever we get it all done. But let me unsolder one side of that and see if it still tests as 70 outside of the circuit. Usually you can test them in circuit, and if it does test wrong, it'll test too low. So instead of saying 25 ohms, it'll test like 2 ohms because something else is shorted. If you're testing from here to here, no matter what's here, usually you'll get 25 ohms because the power is going to take the path of least resistance. But sometimes there's a circuit, there's a capacitor involved or something, and it just doesn't test right. Now on this, there's no capacitor, but we'll see. So I'll take this board off, you remove those 3 screws, and we'll lay it down. It's got a bunch of wires soldered to the back of it, so you can't easily take the whole thing off. But I'll unsolder one side of that, and then we'll test it again and see if it's anywhere near spec out of circuit. Baked. It's baked. So I put a nice new one in there. Look at that. China's best. Okay, the back has already been serviced. I don't remember if we did that last time or what, but the pins have all been resoldered. You have to worry about that. There's no broken solder joints. And, yeah, it's had a bridge rectifier installed. So what I'm going to do is I'm going to put it back together, and then we're going to put it back in the machine, and then we'll test all the voltages on it and see what we're looking like. You could also replace these connectors, but they all look good to me. But we'll put it back in the machine and then see what voltages we've got and see if they make it off the board through the connectors. And we'll look at the pins on the connectors to make sure all of that looks good. It looked like one of them had already been worked on. All right, folks, so we're going to test them. Now, I've got it set on DC. And so you need to hook up your ground. A good place to grab the ground is the bottom leg of this big resistor. It's soldered to the ground. And then you can use the other one and the 5 test points at the top. The first test point, 6.3 volts. I believe that's the general illumination. No, that's AC, isn't it? We'll look into it. 6.3 volts. The second one, 190 volts. That's most certainly the display voltage for the displays. The third one, 13.7 volts. That's the 12 volts, unregulated, that gets turned into the 5 volts that runs all the boards. The fourth one I don't think you can get a measurement from yet because it's AC. The fifth one is 46 volts. That's the solenoids. So that first one, the first 6 volts, 6.3 volts, is the switched illumination. Now, you saw in the manual it said it was supposed to be 5.4 volts, but there's no load on it right now because nothing's plugged in. Okay, so if we switch to AC, we can actually use the same ground point for the neutral of the AC. And then if we test that fourth one, 7.45 volts. That's the general illumination, not the switched illumination. So it actually runs off of AC. And the same thing, it's high because it has no load on it. So none of the light bulbs are turned on right now. Okay, so our voltages on the power supply at least are good. They're within spec or close enough. I'm going to go ahead and mount it on there with the screws and get it all back to where it's supposed to be. All right, I plugged everything back in. We've got lights. So some of that is all right. I don't think the problem's here. I think the problem's going to be over there. So we're working our way that way. So the power comes up to here. The connectors, one of them's been repinned. Another one, about half of it's been repinned, and they all look fine. So the power comes up to here, then it runs out of here up to here. That resistor that I replaced, I don't think would have made the lamps come back because you saw how it was being used. That's not going to make the voltage just completely disappear by that going higher than it was supposed to be. Okay, I'm going to pull out this solenoid driver board next to make sure everything's been done to it. You can see that they have replaced the filter cap at some point. So at least some work's been done to it. So I'm going to pull it out. We're basically just going to check the solder connections on all of the connectors on it to make sure everything's getting a nice, good, solid connection. All right, so here's the board, the solenoid driver board. The power comes up through a connector here, and then this turns it into 5 volts. And then the 190 that you saw comes up through here, and this regulates it. So there's a little potentiometer in there you can turn to adjust the voltage going to the displays. It's supposed to be between like 170 and 210. You can turn it back and forth. I think the manual says 190, but the closer you can get to 170, the longer the displays will last. So we'll see what that's at whenever we put it back in. This area here is controls the solenoids. So the solenoids, since they run on a higher voltage, they're of course separate from everything else. So the lamps have their own section, the switches have their own section, the solenoids have their own section. So this top part is a power supply. And then they're also keeping the chips and the transistors that ground the 50 volt solenoids on this same board, just to keep all the kind of the high power, high voltage stuff in the same area, basically. I guess that's one way of looking at it. So this one's already been serviced, though. Somebody has replaced a chip. That may have been us. I can't remember what we did to it last time. They have resoldered all the connections to ensure that there's no funny business there. Everything looks fine, so there's really not much to upgrade here. They replaced the filter capacitor. It's a little bit too small. It's a 10,000 microfarad, but it's supposed to be an 11.6, an 11.7. You can go higher too. You can do like 12 or 15,000. If they did 10,000, you know what I'm going to do? I'm going to check with Clay. Whatever Clay says, that's what we're going to go with. If Clay says 10,000 is going to work, we're going to leave it. If Clay says it needs to be higher, we're going to change it. So, I learned to repair most of these pinball stuffs from Clay at pinrepair.com by just reading his wonderful website. And he says, when he's talking about this, now this Clay has done a lot of these. He knows his stuff. Filter caps are designed to last about 10 years. So that means all Bally games from 77 to 85 should have their filter capacitor replaced. Replace the filter capacitor with any value from 10 microfarad to 15,000 at 20 volts or higher. If the game had just 2 flippers, 10,000 or 12,000 will work fine. I found a typo. If the game has more than 2 flippers, use 15. Well, there we go. All right, so I'm going to simply clean the pins and put it back in the game. We'll check the voltage on the displays after we do that to make sure it's not way too high. You can replace this filter cap here too on the displays, but usually it doesn't need it. I know, like Clay just said, they wear out, but what'll happen if this goes bad is your displays will do this, or they'll have like a wave going through them because this cap is bad. Even if, you know, it'll just be a nuisance, it won't be anything that'll hurt anything, right? But these aren't doing that. They look fine. So usually you don't have to replace that. I don't think I've replaced it on more than 2 or 3 machines that I've ever done. You can replace it, though, just for the heck of it if you want. Because he's correct. The thing's very old. Now, a human that same age would not be very old. But for a pinball machine, that's old. Really, really old. So I put the board back in. It was missing one of the screws, so I put a replacement screw in it. If you've got all of this stuff grounded well to the back box, it helps with things like resetting and things like that. Also, this ground strap here is important. The same problem. You'll have resets and coils lock on and stuff if you don't have that attached. Okay, so this is the main connector in the freaking game. This is the most important one. That plugs in the bottom left of the MPU board. And it's how the MPU board gets 12 volts, 5 volts, and I think that's it. And ground, of course. I think the solenoid voltage actually comes up there too for the zero crossing detection circuit or something. I don't know how they... Well, whatever. I think the solenoid voltage comes up to the board. Let's see. It'll tell us right there, won't it? Yeah. So test point 2, 43 volts. Test point 3 is a ground. Test point 4 is 5 volts. Test point 5 is the VMA. Okay. And test point 6 is a zero crossing. Test point 1, nowhere to be found. Don't need that one. Okay. So if you look, if you've messed with them enough, you can kind of tell by looking at the edge if the pins are any good on the connector. And they're all pretty shiny. These are actually pretty decent. But what I'm going to do is I'm going to replace these ones on the bottom here because those are the voltage ones. So the bottom, I don't know, 5 or so are the voltages coming in the 5 and the ground and the 43. So you want to make sure that the 5, the 12, and the ground. You want to make sure that those are definitely solid or you'll have problems where the board won't boot or it'll reset and all of that. So I'm going to pull out each one of those wires one by one, repin it, and then put it back in there. Oh, and one thing I should mention is the reason these get messed up is because they get corroded. So the original game board would have had a battery that sits right here, and it leaks over time. And it just starts eating up the board. So it comes over and eats up the bottom of this connector sometimes, and it's really close to this connector. So it will eat up the connection. Now this is a brand new board, so it doesn't have that problem, but it may have traveled up into these pins and corroded them as well. So it's just a good idea to replace them. Some people replace every pin in the game, which you can do that if you want, but I think it's a little over the top. Sometimes you do need to replace a whole bunch of them, though. But so we're going to replace those just for now. I mean, the game is up and running. We're just trying to do whatever preventative maintenance we can to it to make sure that it stays running. Okay, so like I said, those are in the danger zone. Those are the ones most likely to get screwed up, and they look just fine. They're a little dirty, but they're not corroded or anything. I've seen, I mean, a lot of times they'll just fall apart whenever you take them apart. So I think all the pins are fine. So we'll roll with that. Now, if you need to buy any of these, let's say yours is all screwed up. Let me show you a good place you can pick up stuff like that. You want to check out wirebot.xyz. Wirebot. They are a division of Zap Cables. This is a mom and pop place. I think it might even be just a pop place in Madison, Wisconsin. Good old Madison, Wisconsin. And he is a pinball dude, and he sells some wiring and connectors and things like that that kind of have a pinball slant to it, right? So one of the things that he does is he sells these connectors. So he's got the crimp contacts, and he's got the connectors. Now there are two sizes that you are likely to use in pinball machines that get damaged. These 0.100 connectors, which is 0.1 inch, tenth of an inch, the connector itself usually doesn't get damaged because they're not running a lot of power through them, or a lot of amperage through them usually, but the pins do, right? So these are the crimp contacts that you need. If you need the the housings, he's got those too. He also has new headers, and you can see they're affordable, right? And this is the polarizing key. This is cool. Almost looks like he had that 3D printed or something. But that is the little key that goes in one of the pins of the housing so that it won't go in the wrong spot. And then he also has the ones that are 0.156. Right, so 0.156 inches. These are the ones that are like on the power supply. This one gets burnt up a lot. So he's got the contacts. He's got the trifurcon. I always thought it was trifuricon, but that sounds like something from Transformers. Trifurcon, which means that it grabs the pin on three sides. See that little gimmick there on it? This one doesn't have it. That's the ones that are in there already. This one makes it where you grab the pin on three sides, so it just makes a lot better connection. So he's got those as well, and he's got these connector housings. Now that's the big, he emailed me to let me know that he got the big ones in. Let's check it out. All right, we're going to put him to the test. Here we go. Oh, we're going down. Oh, look, what is this down here? 20 position, that's right. And they're only 62 cents. Wow. So these are the ones, the 20 position one is the most popular one. That's the one on the bottom of the power supply. The whole thing is the power supply is directly connected to all of the general illumination lamps. That's all they connect to is the power supply. Now in some of the later games they connected to a relay and stuff too, but since that power supply is providing power to all of the lamps, they run a lot of amps through it. So they slap the hell up after a while. And those pins will get so hot that sometimes they'll desolder from the board, and many times they will melt the nylon little connector. So it's not uncommon to get an old early Bally and this connector, the 20-pin connector, will just be fried, all melted up and brown, and you can just tell. And it'll only be on a couple pins, and one of them's kind of like right in the middle. It's like this one will get so hot that it breaks the connector in half. Whenever you go to remove it, one side will come off and the other side will still be there. And then the other one will be down at the end, and it gets all screwed up. And then you have the problem where whenever you pull the connector off, the end pins always get bent as you pull the connector off because, you know, it always comes off a little crooked. And so the pins on the end get cold solder joints, and then you're running a lot of amps through them, so it will just create so much heat and resistance it'll screw up this connector. So if you need replacement connectors, this is a good place to get them. Wirebot.xyz. And he's got other stuff, ribbon cables. He's got harnesses for some of the classic games and stuff. He's got some tools. wire management, which it would be clips and things like that. And then, of course, he's got wire. So check him out. I support him wholeheartedly. He's doing a great job and has all the cool products. Some of this stuff has been hard to find for a few years now, but he put together this website, and dude does a great job and has great parts. So I can't recommend him highly enough. So go stock up because they're oh so cheap. So it is booted again. We need to figure out the light situation next. There's also one of the displays has screwed up. That flickering you see is just the camera. Here in person you can't see that with your naked eye. But the lamps, a whole bunch of them appear to not be working. They're either burned out or something. So in a Bally, one of these classic ones, if you just hit this button once, it's the test button. It'll take you in, and it will. The first thing that it does is flash all of the bulbs. So we've got a few burnout. These are general illumination. Look at that. I got the magic touch. Let's try it again. Look, my powers only work on some. It's not. Look there. That one worked. Okay, so I'll go ahead and swap the ones there that aren't working. And then we'll close this back up. And I need to lift up the playfield and start replacing them under the playfield just to see if the reason, if any of them, it's not the bulb, it's something with the board. So you got to keep in mind too, this is a very early solid state game, so they didn't really have much of an attract mode. So there's just a couple lights that move around because people weren't used to having lights that moved around at all, like on a EM. Like this beautiful royal flush here, there was no attract mode. There were no lights blinking or anything. So it was a new thing. Okay, so yeah, let me fix the ones that aren't working, and then I'll close that board up, and then we can start swapping the ones underneath the playfield and see if that fixes all of them or if there's some that still need replaced. Okay, so all of those are working, and I replaced every single one on the bottom of the playfield, and they're all working with the exception of this 5X bonus one. I can't get it to work no matter what. The rest of them that aren't working are just general illumination. It's just you replace the bulb and it'll fix it, but they're under light shields and stuff like that, and we still have to clean the whole playfield. So the 5X bonus, we might be able to wiggle the connector. Oh, come on. You sucker. Trying to help. If I'm trying to help, you'd think it would cooperate. So 5X, we may be able to wiggle the connector and get that to light up. If we do, then that means it's the pin or the connection. Nope. Okay, another thing that's interesting, I'll just show you. Look at all the empty connections on the lamp driver board connector. So basically they didn't use a lot of the transistors. They still had room. So they designed this board and it could run a certain number of lamps. And then they would have to put it in the harness and wire it up on the playfield. But they still had several that, each one of these little holes is connected to one of these transistors. So they still had more that they could control, they just didn't use them all. Okay, so I'll look up in the manual which transistor does the 5X, and then we'll pull this board out and we'll swap that transistor and see if that fixes it. So here's the lamp board. I removed its transistor Q21. I removed it, I tested it, it doesn't test bad. However, these SCRs specifically are hard to test for me. Like a lot of times they'll test just fine and they're not fine. So I went ahead and swapped it. It was Q21. So I got a new one. So the way this works is this connector is the MPU board is connecting to this. There's also a power connection here. I think it's the 5 volts we were talking about. And then uses these 4 decoders to basically control all of these. So all of these, actually, that's not 5 volts, I don't think. Well, it must be because these need 5 volts. Anyway, it syncs all of these to ground to turn on the light. These ones in the middle, some of them control 2 lamps. Or can control 2 lamps because it's a slightly different part. And this board is the same in every early Bally game and every early Stern game. Some of the Bally games ended up having a ton of lamps, so they just put 2 of these boards in there. And they're able to control it with the strobe and just signals from the MPU. So it worked great. But you need a wire, 1 wire to each lamp doing that. So it doesn't use a matrix. It uses an individual wire for each lamp. So if you look on the back, these connectors have never been reflowed, and this is a common problem on any of these boards. We were just looking at the connectors you can get from that website. This is what you might need them for. These don't look that bad, but I'm going to clean them up, and I'm going to resolder them. Are you dizzy? We're traveling. Pretty bad connection up there. Alright, so like I said, I'm going to clean them up, resolder them, make sure they're making good connections, and then we'll put it back in the game and see if that fixed our 1 lamp that wouldn't work, and we'll see if I somehow broke any of the other ones just messing with it. Okay, so that got it back. The green one's lighting too, it's just filthy. And this green one. So all of the lamps are working. What do you think about that? So for my next trick, if we hit the button again. Okay, you can't see this too good because it's showing it's strobing. Now this is fun. So the electricity you're seeing there, the Frankenstein, that's real. You can see that with your eye. So they have that right there in that display because that's the one that doesn't use all of the digits. And it's on free play. So I think it uses these 2 and these 2. So that one isn't actually used. Okay, but this one is. So one of the digits doesn't work. That's not good. All right, so let's check the voltage going to them to make sure that we're not over voltaging them. Make sure that the voltage isn't too high, and then we'll remove that first one and see if we can figure out why that 1 digit won't light up. It's a resistor. Let's go meet the resistor. All right, so back to the solenoid board. I checked the voltage. It was at 250 volts, so it's not regulating at all. So something in here is shorted, and it did not blow the fuse. Okay, so you've got 3 things that you need to check. Well, you got several things you need to check. This transistor, this transistor, this transistor. And then there are 2 diodes. One here and one here. And then this resistor often burns slap up. And this one doesn't want to disappoint. So we're going to check and see if this is shorted, or this is shorted. And if any of them are, we're going to remove them. We're going to check and see if either one of the 2 diodes is shorted. And then we're going to remove this resistor and replace it as well. And all of those values for all of that are in the schematics. The schematics are available all over the place. If you don't have yours, you can get them online. A good place to buy stuff like that, if you want the good quality paper copies, is Pinball Resource. Go to pbresource.com. Pinball Resource. They sell all of the paperwork, and they can sell you the parts and everything you need. So I'm going to use my diode check again, and just check these 3 transistors and see if any of them test shorted, and see what we've got a problem with. Then we'll look at it on the schematics. Okay, so I've had this exact same thing happen before. This one was shorted. This one was open. And the resistor was burnt up. The diode's fine. The diode's fine. I replaced the potentiometer because those things suck. These Bally, these little potentiometers Bally used, these are horrible. The Gottlieb ones are really bad too on the early like System 1 stuff. And System 80 and System 3 power supplies. If you see a little potentiometer that looks like this, it ain't long for the world. Go ahead and put a new one in. Spend that 50 cents. So I put a new one in there. It's not quite as nice as this because it doesn't have the thumb wheel, but you can still reach through that little hole there and adjust it with a screwdriver or something. Which you had to do on that really anyway. Like you couldn't just reach up there and adjust it because you had this on it, right? So there was a little hole so you could do it with a screwdriver. All right. Anyway, so this resistor burnt up. This one shorted. And this one opened. So you can decide why that happened. So the 253 or the 230 volts, or it was 253 volts that was here, since this was shorted, just passed right through and was what we were getting over here. Adjusting the potentiometer didn't do anything because it was shorted through this transistor. So that's a 2N3440, and that is as well. Right, so there's your schematic, and you can figure out why it did what it did. They do this often. I had another one that did the exact same thing, and I did a video on it. I can't remember which machine it was, though. It was about a year ago here on the channel. So I keep these in stock just to replace this. Now I know what you're saying. Why didn't it blow the fuse? Because why would it? It didn't increase the amperage going through it. It just increased the voltage. So it went from 190 to 250. And that fuse just was very happy with it. So I checked the fuse, and it's the original, and it's the correct 3/16 amp. But the amperage didn't increase. The display still pulled the same amperage. Now I know the other thing that you're thinking. What about LED displays? I love LED displays. They're fine. These plasmas burn up after a while, and the LEDs are a good way to replace them. But they cost money. These ones are already in there. I can repair it. So we're going to just repair it. There is still some life left in the plasma displays that they mounted in one of the 20 Matahari prototype pinball machines. Okay, so I adjusted it to 173 volts, and it got rid of the little short that we were seeing. That was scary. And everything looks good except we're missing that digit and we're missing that digit. So I'll pull out that first one and we'll see if that'll fix it. I wonder if I back up if you can see it better. Maybe if I zoom in, it won't do the flicker thing. No, I can see it from here. That looks a little more like what it looks like here in person. They're not flickering at all. Okay. All right, so let me pull this one out. It's probably got a burn-up resistor on it. Okay, there's several different versions of these, but what you want to look for is resistor R1. It's 100K ohms. So that does this digit. And then resistor R3 does the next digit. And then resistor R5 does the next digit. Now I have been checking these, and believe it or not, resistor R5, as pretty as it is completely flat open. It's not connected in there at all. That thing is burnt up. You can't tell by looking at it, but it is. Trust me, I can't show you. Let me see if I can try to show you. You probably won't even believe me though if I do show you. It's such a beautiful little resistor, and it don't work. Alright, so that's R5. Nothing. Dead as hell. Now let me do R3 just to show you that my chopstick method works. There's R3. Supposed to be 100K. It's 104.8 because it's 5%er. Now just one more time just for giggles. R5. Nothing. And whenever I don't have the camera on, I even use two hands. And the thing, it ain't connected, folks. So it needs a new one for sure. So if we replace that, it should bring that digit back. Now, you might just be saying, well, how did you know that? It's because it does this on every one of these displays. Basically, that's the first thing that the juice hits. Look, I realize I'm using layman's terms, okay? It's getting late. That's the first thing the juice hits. And then whenever, after a while, it gives up the ghost. So to prove it, I'm just going to replace that one resistor, then pop it back in, and we'll see if it works. Now, it could be some of these transistors. But that ain't what it is. If that resistor's burn up, the damn thing ain't going to work. And this is super common. It happens all the time. So I'm going to swap out one resistor, and then we'll put it back in there and see if it works. All right, folks. The one resistor did it. Very cool. I wonder if the ball and play one is locked on. We'll figure that out some other time. So there you go. I hope you enjoyed it. On the next video, we'll work on the play field, clean it up as best we can. It's got some pretty heavy wear on it, but we're not going to do anything with that. We're just trying to get it where the gentleman can play it and have it in his rental and make it as reliable as we can. So hopefully, we've turned it on like 20 times already, and it came up every time. So I think we had some connection problems. But now we've got all the lights working. It's really starting to get there. Got the displays working right again. And we've still got to mess with the switches. One of these drop targets is broken. Another one's pretty ugly. So we'll see what we can do about that. And we've got to clean up this play field. So we'll do that on the next one, and then we'll play it a little bit. Just to show you what it's like. We played it on the last video, but everything's so dirty we don't want to, harm the playfield by playing it like that. All right, so we'll see you on the next one. I hope you enjoyed it. Now, if you like these classic old Ballys, these are some of my very favorites. Check this out where we worked on another one back in the day. We'll see you on the next video.